Okay, so in all the examples we've done so far, it's always been just one solution, right? So let's say this is a theorem for a system of linear equations. There are exactly three possibilities. One, you could have just no solution at all. Two, you could have a unique solution. Okay, this is what I guess this is what you're hoping for. This is what we've done so far. Okay, you can imagine two lines intersecting in a single point. And the only other possibility is, in fact, infinitely many solutions. Okay, let's motivate this a little bit in blue. Let's just say, example, okay, for what does it look like when you have no solution? Well, something like x plus y is equal to 0, but x plus y is also equal to, say, 1. When I draw this, what do I get? You get a line going like, oh boy, a line going like this. And then at 1, you get another line going parallel. Okay, so there's no intersection, right? Okay, here you can see it, x plus y can't be 0 and 1 at the same time. Two, unique solution. Okay, this is, at least when you have two equations, two variables, this would look something like this. You got a line here. Ooh, that's not, you have a line here, and you have another line, and you have this intersection point. Let's say 10 and 9, whatever. So the lines intersect in exactly one place, so a unique solution. Infinitely many solutions. Okay, it's when you have just two equations, two variables, that's not very interesting. Let's not do the axes yet. You could have something like 2x minus 3y is equal to 1, and you have minus 6x plus 9y is equal to minus 3. So with this system, at first glance, the equations look different, but they're actually the same equation, right? If I divide by -3 there, I get 2x minus 3y is 1. So it's the same line. Okay, so you have two lines that are, well, they're not two lines, they're just one line. Okay, so what is the intersection? Well, it's every point on the line. Now what have I done? So managed to choose a system that's, how do I graph that quickly? So the quickest way to draw a graph is to do, of a line, is to just plug in, just do intercepts. So when x is 0, y is negative a third. Oh, that's nice. So looking here, when x is 0, y is negative a third, we'll say that's right here. And when y is 0, you get x is plus a half. We'll say that's right here. And the first line goes like this. Bloop. And of course, to infinity in both directions. And the second line is, well, exactly the same thing. So the solution is the set of all intersection points. So you can see there are an infinity of intersection points there. Okay, so this, I've drawn some pictures for the case of two equations, two variables. But this theorem is true for any cases, like 5 equations, 6 variables, 6 equations, 7 variables. Every one of those are going to fall into one of these categories. Okay, every single system of linear equations is going to be one of these 3 things. There's nothing in between. I can't have, say, 10 solutions. If I have more than one, then I automatically have an infinity of solutions. Okay, what else do I want to say? Okay, we got some more words here. No solution is, we also say that system is inconsistent. Now, when you have 2 or 3, scenario 2 or 3, we say system is consistent. Okay, if there's at least one solution. So inconsistent versus consistent.